Okay, today we're moving right along to lesson 1.12. I hope you found it helpful to watch the video for 1.11 yesterday, because today's skill builds on top of yesterday's skill. That's how math works in general, okay? And today your learning goal is to multiply a decimal by a whole number, but instead of using an area model today, you're not only going to use an area model, but you're also going to use estimation to make sure your answer is reasonable. But first, let's talk about the problem of the day. It says Patty buys 6 juice boxes each month for lunch, okay? If one juice box costs $1.21, how much money does Patty spend on juice each month? What is the problem asking? Kevin?
How much money does Patty spend on juice each month?
Yeah, we're trying to figure out how much money she's spending each month. What important information do we need in order to solve the problem? Visisht?
6 juice boxes, $1.21.
Okay, so we know that she buys 6 juice boxes and each one is $1.21. So how can we find out the total amount she needs to spend? Itai?
We can multiply $1.21 by 6.
Yeah, we can multiply 121 cents, $1.21 by 6. And let's use an area model, which is also sometimes called a tape diagram, to solve. So if you didn't do it this way, I want you to draw this in. Okay, if you for some reason already know the standard algorithm, I'm not looking for that. I'm looking for area models. If you did repeated addition, that's great, but I'm looking for an area model right now. Okay, so let's split up this piece of tape, or this area, into the ones, the tenths, and the hundredths. How many ones do I have in my dollar amount? Arhan?
1.
I have 1. Okay. How many tenths do I have, Tara?
2.
2 tenths. How many hundredths do I have, Sporty?
100.
100th. And I'm multiplying those numbers by what, Roni?
Multiplying them by 6.
I'm multiplying by 6. Okay, so the area of this first piece of tape is 6 times 1, otherwise known as how many ones? 6 ones. Good. Okay, the area of this second piece of tape is 6 times 2 tenths, otherwise known as how many tenths, Zeev? 6 times 2 is 12 tenths. Okay, and then the area of this third piece of tape over here is 6 times 100th, otherwise known as what, Arun? 600ths. Okay, now I need to write all these in standard form. So 6 ones in standard form, Ella, is what number?
6.
6? Okay, thank you. 12 tenths in standard form, Aditi, is 1.2. 600ths in standard form, Alex, is?
0.06.
You got it, 0.06. So in order to find the total area of this piece of tape, since we're calling it a tape diagram today, we need to add these numbers together. So I have 6 plus 1.2 plus 0.06. Am I ready to add?
Yeah. No.
Why am I not yet ready to add? Arhan?
You're not ready to add because not all of them aren't lined up.
You got it. I'm not ready to add yet because the place values aren't lined up. It's a little bit tricky because I don't have the same number of digits in each number. So it's very easy to make fabulous fails here. How many of you guys made this fabulous fail in your homework? Be proud, because that means you learn from it. Raise your hand right now if you made this fabulous fail either on your homework or in your practice problems. I'm so glad you're raising your hand and being proud of that, because guess what? Are you ever going to make that mistake again?
Nope.
No. Okay. So 6, 1.2, 0.06. Now am I ready to add?
Nope.
Well, I need to add a decimal point and some zeros, right? There we go. Now I'm ready to add. So 0 plus 6 hundredths is how many hundredths?
6.
Okay. 0 plus 2 tenths plus 0 equals how many tenths? 6 ones plus 1 is?
7.
So Patty will spend $7.26 each month on juice. In your math notebook, I want you to write down these 3 math problems, exactly as written. 31 times 4, 3.1 times 4, 0.31 times 4. So what I hear Drew saying is that these 3 problems are alike because they all have the same digits. What digits are involved in these problems? Sonia?
3.
They all have a 3.
3, 1, and 4.
They all have a 3, they all have a 1, and they all have a 4. But are those 3 problems exactly the same?
No.
No. What makes them different is the place value that the digits are in, right? So let's use these area models, otherwise known as tape diagrams, good, to solve each problem. So if I have 31 times 4, I can split that up into, how many 10s do I have? How many 10s are in 31? 3 10s. And how many 1s are in 31? 1. Go ahead and write this in your notebook while I'm doing it too. And I'm multiplying that by 4. So the area of this section is 4 times 3 tenths, otherwise known as how many tenths? 12 tenths. And then the area of this other part is 4 times 1, otherwise known as how many ones?
4 ones.
So if I have, what's the standard form of 12 tenths? I write the digits, and I want this digit to be in the tens place, so I have to add a 0. So it's 120. What's the standard form of 4 ones? It's 4. Good. So the product, 120 plus 4 is 124. So we know that 31 times 4 is the same as 124. Go ahead and write that down. Now let's try this next one. 3.1 times 4. I'm going to use this tape model, or area model here. Do I have any 10s this time?
No.
Do I have any 1s?
Yes.
How many 1s do I have, Lakshan?
We have 3 ones.
3 1s. And how many tenths?
1.
1 tenth. Okay. And I'm multiplying that by 4, so the area of this part would be 4 times 3 1s, which is 12 1s. And then the area of this part is 4 times 1 tenth, which is 4 tenths. I know that the standard form of 12 ones is 12, and then the standard form of 4 tenths is 0.4, and I can add that. I know that that equals 12.4. So I know that 3.1 times 4 is 12.4. Okay, good. Now moving along to my third problem, I don't have any 10s, I don't have any 1s, but I do have 3 tenths, and I have 1/100th this time, and I'm multiplying that by 4. Okay. To find the area of this part, I need to do 4 times 3 tenths, which is how many tenths? 4 times 3 is 12 tenths, good. And over here, to find the area of this next part of the tape, I have 4 times 1/100th. 4 times 1/100th is how many hundredths, Ben?
4.
Okay, make sure you're writing this down. If I have 12 tenths, I know the standard form is 1.2. And then if I have 4/100ths, I know the standard form is 0.04. So that equals 1.24. Therefore, 0.31 times 4 is equal to 1.24. We talked about how these 3 multiplication problems were similar because they all have the same digits, just in different place values. Now take a look at the products. Remember, products are the answers to multiplication equations. So let's look at this one. This is 124. This one's 12.4. This one's 1.24. How are these products alike? How are they the same? Aditya?
Oh, they're alike because the digit is always a 1, the second digit is always a 2, the third digit is always a 4.
You got it. Aditya said these 3 products are alike because the first digit is always a 1, the second digit is always a 2, and the third digit is always a 4. How are these 3 products different, Arhan?
They have a decimal point in different areas.
They're different because their decimal points are in different places. In the first answer, 124, where is the decimal point? Ah, it's after the 4. In the second product, 12.4, the decimal point is in between the 2 and the 4. In the last product, 1.24, the decimal point is in between the 1 and the 2. When the decimal point is in different places, it gives that number a different value, doesn't it? Okay, let's take a look at that. 5.1 is pretty close to what number? Like, what whole number is 5.1 pretty close to? Lakshan?
5.
Yeah, so we can think in our heads, we can estimate that 5.1 is pretty close to 5. And in our heads, can we just do 5 times 6 really quickly? We know that 5 times 6 is 30. So we know that our answer, because 5.1 is pretty close to 5, we know that our answer should be pretty close to what number? 30, okay? Now, that I want you to draw a little thought bubble because that's what you're thinking in your head. So draw a little thought bubble in your notebook and then write this down. In order to actually solve it, let's think about 5.1 is the same as how many tenths? 5.1 is the same as how many tenths? Arun?
51.
51 tenths. So this is the same as doing 51 tenths times 6. Well, then I can just do 51 times 6. And we know how to do this kind of multiplication, yes? 6 times 1 is 6. And then 6 times 50 is 300, right? Good. So I have 306. Now if I know my answer, because I did my estimate, is supposed to be pretty close to 30, where would I need to put that decimal point to make this answer pretty close to 30? I would need to put the decimal point between the 0 and the 6. Okay, so therefore my answer is 30.6.